Welcome, everyone. It's just the top of the hour. I'd like to go ahead and get started. Let me just move over to my slides. So the session today is on teaching qualitative data analysis with MAXQDA. And I'd like to start by telling you a little bit about the course or workshop format. I typically teach a week-long course or sometimes a 2-day course. And I really like to mix things up between lecture, discussion, software demonstrations, and analysis application. I find that too much of any one thing gets really difficult to handle in a workshop. People get tired. So I like to mix things up as much as I possibly can. So for example, I may do a lecture on the tools and processes of analysis, which I'll describe a little bit more in detail in a moment. I have typically a discussion of a few articles with different analytic approaches, an introduction of MAXQDA with a fully built project so they can see sort of the end result before we get into the nitty-gritty of individual functions. And then I also like to show them a basic search with activation so that they can see what it looks like to review some coded segments and memos. So let me talk a little bit about how I like to lay the foundation for a workshop. My core lecture typically focuses on the distinction between the primary data, the tools that we incorporate into the data, and the processes of data analysis, which may be multiple different processes. I like to do this for novice learners because it gives kind of an overview of the content of the full session. It explains key terms, so understanding what segments, codes, etc. are. And it also introduces the notion of multiple processes of analysis, and that you might take a different process for thematic analysis versus grounded theory, for instance. For experienced researchers, I find that this core lecture is really useful in establishing common vocabulary and makes explicit the approach and potential for lack of consensus. So we want to make sure that we all are using the same terms when we're talking about things like codes, categories, properties, and dimensions. So this fundamental lecture on primary data tools and processes of analysis does that for me. So I talk about how primary data is the foundation for a project, and then we build in memos, codes, segments, and variables. And for each of those, I give a little bit of an explanation that memos annotate data, codes provide your search terms, segments are actually the unit of analysis. It's the block of text that you retrieve when you're doing searches. And variables are discrete information that are not typically amenable to textual analysis, but they present categories or types for comparison across the data. I also talk about the process of analysis as one of retrieval, review, reflecting, and reducing the data. So simple searches use activation to use code as search, and use those codes to search. We typically retrieve both coded segments and any memos that we may have incorporated into the data set already. Complex searches may include variables as well as codes and code combinations to retrieve coded segments and to compare data to other groups by variable values. And finally, we use these processes to reduce patterns and variations into descriptive and comparative accounts. I like to use a few empirical articles that demonstrate strong processes of analysis. I have 3 articles, one that focuses on a memo-driven strategy, one focuses more on case-based analysis, and a third that focuses on thematic analysis. And this helps to establish that different processes can be used, still using the same tools. We'll still use memos and codes, etc., variables, but the processes of analysis are a little bit different. I also like to choose articles that really demonstrate a transparent way of writing about analysis. It's not enough to say we analyze the data using MAXQDA software, but we really want to describe the process of analysis from start to finish. When I'm doing these, doing workshops and using these articles, I typically have them read the articles in advance and then ask them in small groups to review the method section, and then come back and explain what their findings to the group as a whole. So I may divide the group into three smaller groups and have each one focus on a single article, although everyone has read that article beforehand. I like to give an overview of a fully built project. It allows me to demonstrate the key features and functions of the program in a way that doesn't overwhelm them. I don't ever give a complete point and click. This is what each function is based on each icon on a particular ribbon. I really just want to show the overall, these are what the windows look like, and this is how to open and close them. What do codes and coding stripes look like? What does segmentation look like? Where are all the memos in your document? Where can you put them? And basic overviews of activation, both by code and also by variables. This is not typically this is a point and click demonstration. It's not one that I'm asking them to follow along. And it's really meant to just orient learners to the program. So practical considerations that you might want to think about. It's essential for your students to be able to practice the skills with real data. And I provide secondary data for at least the first half of a course, whether this is a 2-day course or it's a semester-long course. I find that when students bring their own primary data, their learning depends on the quality of that data. A lot of students really want to work with their own data, but I find that if I provide some good, strong secondary data for at least the first half of the course, they learn basic skills that they can then apply to their data no matter what the quality of that data is. It also provides a basis for a lot of team-based analysis exercises. So if everybody's working on the same data, you can put people in small groups to review each other's memos, to review each other's coding, and it really helps model this team-based process. If you're working with a client and they want to use their own data for a workshop, you really want to assess whether the data is rich and thick enough to demonstrate the key concepts and skills that they're wanting to learn. And you want to ask yourself if you can become familiar enough with the data to be able to develop meaningful exercises and discussion. This is an investment in the process. So certainly if it makes sense to do that, it can be beneficial. I often still do that initial demonstration of the data and of the program using my own data because I know what all is built into that data set and that I can demonstrate a full range of what the program can do. So I usually have a project with 4 life history interview transcripts. They're a good 30 pages apiece. During the workshop, each learner will focus on 1 transcript. So in my classes where I have 25 students, it may be 6 or 7 learners per transcript. And then we alternate between individual software practice and team-based analysis discussions. These are just some logistics that I like to recommend that, I typically work in 3-hour blocks with a break in between the blocks. And even in those 3-hour blocks, I like to mix up what we're doing with really no more than about 60 minutes of lecture at any point in time. Depending on the length of the workshop, I may give learners an opportunity to spend up to 60 minutes doing software practice on a particular activity, whether it's writing memos or segmenting and coding data. And then we always debrief what we've been doing after after one of those individual practice sessions or the group sessions where they're talking through what they did with each other. Learners really want to learn about how to do qualitative data analysis, at least in my experience, in a linear way. And we know that it's an iterative process when it comes right down to it, but it's helpful to try to lay it out as a linear process. And then sort of towards the end of the workshop or the course, you can talk a little bit more about different approaches to analysis, how grounded theory is different from thematic analysis, for instance, and how the tools might be used in a different process over the course of an analysis project. I typically start with memos, largely because I think memos are one of the most underused tools in qualitative data analysis. But it's also a great way to get learners to start interacting with your course data. I start with an interactive lecture with oral practice and write down exercises. Then I give a very brief demonstration. So typically now they've seen about a 20-minute demonstration of my full project. And then I'll give them about a 10-minute demonstration of how to write text memos only. Don't go through all the other types of memos until after this process. And then I give them a clean project with only the data, and they practice writing memos on one transcript for maybe 30 minutes to an hour, depending on how long the workshop is. Then I briefly describe the difference between merge and teamwork functions and ask them to export teamwork so that I can bring all the teamwork files together in a single file. Now, this takes a little bit of time when I have 25 learners, but it's a really great process for them to be able to review each other's memos on the same transcript and to really start thinking about the themes that they're seeing in the data. One of the things I really like to do as much as I possibly can, and I'll give you a couple of examples here, is to develop concrete examples. I think many of the tasks that we undertake in qualitative analysis are quite abstract, and they can be difficult for learners to understand and remember in the long term. So, don't be afraid to develop concrete examples, and especially if they're a little bit silly and they'll be memorable later. Probably my favorite example of this is I talk about Hawaiian shirts, and I've done this workshop in a lot of different contexts, and it seems like everybody has kind of a notion of what a Hawaiian shirt looks like. And I use this as an example of how important it is to develop code definitions. So I give them this scenario that you're the costume designer for a theater production of an old Elvis movie, and your buyer is going to a nearby city to purchase Hawaiian shirts for the projection and needs instructions on what to buy. So we start by just coming up with the definition. What is a Hawaiian shirt? And of course, people talk about it's collared, it's buttoned down, it's loose fitting, it's bright colored, it has maybe a floral theme. So we list all these things and see if we pretty much agree that we've got a full definition of what a Hawaiian shirt looks like. And then I give them some pictures and I say, which of these shirts is actually a Hawaiian shirt based on the definition that we've developed so far. And inevitably, number 3 in this list, they might say, oh, well, it's not bright enough, or maybe number 4, it shouldn't have such dark colors. But we work through sort of why it is that we want to select the shirts that we do in this list. And then I give them another set of images that have pictures of people and not just the shirts, because I think it's really important to make the point that context is important. And when we see hipster bachelor number 4 on the right, who looks kind of like a hipster, and maybe his shirt isn't that snug, or it's more snug than it should be to be classified as a Hawaiian shirt, students start to see that context matters. And this is a great demonstration of how we can get distracted by what else is going on in the data and maybe not see our themes as clearly as we might normally. So, so part of what I do in this, I also change the scenario at the end. So I try to make the points that, it's important to interact with your data whenever you're developing code definitions. Sometimes a definition may seem just great, but when you actually interact with the data, it isn't quite as clear as you thought it was. And also that you want to interact with data in context to make sure that you're understanding the full sort of complexity of what's involved in that. And then finally, I change the scenario. So I say, if you're holding a themed birthday party for your 75-year-old uncle, who would you turn away? And make the point that really your research question also matters. It's not just based on your code definition out of the context of what you're looking at and what's theoretically important. Let me just stop for a quick minute. I want to see how I'm doing on time and see if there are any quick handouts or any quick questions before I move on. Matthew asks advice on how to teach QDA to people with no qualitative or research background. Actually, most of the work that I do, I typically am working with people who do have at least an introduction to qualitative methods, but really no background in analysis. But I think there are enough similarities to even thinking about things like social media that you find themes and you annotate things that I think you should be able to make analogies to everyday processes. I do find it's typically difficult to teach qualitative analysis to folks who are quantitatively trained if they don't have some background in things like the philosophy behind qualitative data collection, things like saturation. So I would recommend, you may want to back up a little bit in your teaching and go over some of those basic qualitative principles before jumping straight into analysis. So let me come back to my slides. So when we do codebook development in one of my workshops, I typically will, so for instance, in the data set that I give them, we have codes that are well defined and that have been applied to the data. And I usually use those same definitions for a handful of codes. But I also try to brainstorm some codes with my participants. And I usually like to have at least one of those codes have a relatively bad definition. That is to say, a definition that's going to be difficult to apply. Because I think it's important for students or learners to understand what it feels like to try to apply poorly defined codes. I give them time to code their transcript, to export their teamwork, and when all the files are combined, they review and discuss discrepancies in their code application and talk ultimately about how they can improve definitions to make it really clear when those codes should be applied or not. Sometimes we'll add inclusion and exclusion criteria. So this is an example. This is a data set that's got about maybe 10 different coders. And so it gets really messy. I typically will have, you can see in the code system, I'll ask students to add their own name to the end of the code name. This bypasses any combining of coded segments that are common among different learners. So this way the program reads each of these codes as a separate code. but we can see them clearly in the code margin. I then show them how to right-click. If you right-click in this area where the coding bars appear, you can activate the code that you want to look at and select only activated code so that you have a streamlined view of the code that you're interested in reviewing. And I'll have them go through a section like this and say, oh, okay, only one person coded paragraph 170. So let's everybody read that paragraph and decide if the code alcohol and substances applies in this particular paragraph. In the second example down below, there are 3 people who coded. And I should say that although I've got about 10 people who have coded this particular code, they've all worked on different transcripts. So probably only 3 people did code this particular transcript. And the only difference here, as you see, is segmentation. And I typically don't focus as much on segmentation differences as I do on the actual question, does the code apply or not? So once we've gone through sort of understanding how to apply codes, how to work through defining codes, and working through those definitions through interaction with the data, I start talking more about identifying properties and dimensions within a data set. And I find that novice analysts often have difficulty imagining different ways to describe and characterize coded data. We want to talk about patterns and variations in the data. And it can be a little bit more difficult to sort of visualize what properties and dimensions are. So I use this exercise with fruit, and I'll just show you the image here. So on paper, I'll print these out on index cards and ask students in groups of 3 or 4 students to do a couple of things. So first I'll ask them to sort their fruit into some kind of pile or property, into categories. So sometimes they'll sort them into types of fruit, like whether they're berries or citrus fruit, or how they grow. And then I also ask them to put them on a continuum of some sort. So that could be the sweetness of the fruit itself or the edibility of the skin. So they'll take each of these individual images of fruit and do kind of a pile sort, and then do something along a dimension. And I find that this is really helpful afterwards when we're talking about, and they come back to this question as, well, what do you mean by properties and dimensions? It's a very concrete example that people can come back to and say, you know, remember, these are aspects of the theme that you're examining. These are components, and they may be categorical or they may be continuous, but you want to be able to think about how to sort all of the data you have in your data set into different properties or different dimensions and be able to describe them. So I typically will have focused on thematic analysis during an introductory workshop. And at the end of the workshop, I may go through a couple of different approaches to analysis and describe what those look like and how the processes are different. I like to review strategies for presenting data. So I've got a great paper that has about a dozen different ways that they present data, whether it's lists and case studies and quotes. So I like to have them go through that report and identify all the different ways that they use to present data. I like to go back to those analysis papers that we looked at the beginning of the session and really assess the analysis and the results that they present. And I really recommend assessing the workshop as well. I find that I do a brief oral evaluation of the workshop and ask, you know, what did they really like about the workshop? What should I keep next time I do it? and what might I improve for the next time around. And I find I get really, really helpful comments from participants in the workshop at that point. Just have one more slide, and it looks like we're really good on time. So the final, when I teach this as a course, I have a final assignment, and I give the final project to students. So it already has all the memos that they've written. It has final coded data. I asked them to write up an overview of one code. So tell me about sort of what's the principal finding in that particular code, how much variation is there, what are similarities and differences among participants. I asked them to select one property or dimension of the code and describe that, and to show me how they've analyzed that data using MaxMaps. I like to ask them to compare the data for two groups on that particular code. The data set that I give them has both African American and Puerto Rican participants, so that's one obvious comparison they can make, although there are others. And then I asked them to also describe an intersection with another code in the data set. So they have to actually go in and do a search on intersections and think about how those two codes work together. And this typically is not a super long assignment. I would say it usually takes students for this data about 8 hours to complete. And of course, you can always come up with smaller exercises in other workshops that simulate some of these processes. So I'm going to go ahead and stop there, and would love to entertain any questions that you might have. Please go ahead and post them in the Q&A. I'm happy to also look at the chat. I'll look over at the Q&A now and look for questions that you might have. I once learned that visualization is mainly good while analyzing, but it can also be useful for your final presentation. I agree. I think I like to use visualization in my analysis process, and I encourage students to do so as well. I think with a lot of the visualization tools in MAXQDA, we need to be really careful to know what it is that we're visualizing. And I just tend to ask students, to really think about when they're getting numbers on the number of times there are intersections, for instance, or the number of times something is coded. I ask them to be sure that they're thinking about their segmentation processes. Are they using large segments or small segments, and how might that affect the differences in coding numbers, for instance? But I do think that images can replace 1,000 words. It's an old adage, but it really is true. I think I tend to use visualization tools along with word description. So it gives you a quick image of what's going on in the data, and then you can also describe it in a more qualitative way. Thanks for that question, Sylvia. Have you had a chance to use the new QTT function? And if so, how have you found using it with your students? I unfortunately have not had a chance to explore that, that function very much. I think it will be very useful with my students, but I really need to explore it a little bit more myself. It's definitely something that I would use towards the end of a workshop when you already have a fully built project, so that you can really start bringing things in from different areas of the program into that QTT function. Thanks for that question, Sharon. Any other questions? Danielle has a comment here. QTT can be great for thinking through all aspects of the project in one convenient area, as opposed to going back and forth between tools. Yep, great comment. Thanks, Danielle. I often will go through the basics and then do some sort of bells and whistles at the end of a workshop, so that I'm teaching this kind of linear process, and then can show them some of the more advanced functions towards the end of the workshop. Loretta asks, I assume you've taught other software programs to students. Why did I settle on MAXQDA? I've worked extensively with Atlas TI. It's been a while since I've used that program, but I at one time was a master user of Atlas TI as well. Not so much with NVivo, but really I settled on MAXQDA largely because it's so user-friendly. I find that I can get students started working in the program in 5 or 10 minutes. I usually only show them one function at a time to get them started working with their data. But it's the learning curve is really easy, and students really respond well to it. So that's largely why I've settled on MAXQDA. Sharon, that's absolutely true. We used to use a lab-based, so we would go in through Citrix and have everybody work from the virtual environment. But now I have everybody bring their own computer and just install the demo on their computer, and it's really fantastic that it works the same way between people who have a PC and those who are working on a Mac. All right, well, if there are no other questions, I'll stick around for a couple of minutes yet, but thank you so much for being here, and certainly be in touch if you do have questions. I'm happy to respond. My dog is here trying to get my attention. So Melvin, I don't think you're off topic. The difference between the paraphrase and summary functions. I typically think of the paraphrase function as something that you would use early in an analysis project, where you're really doing a brief summary of a specific bit of text. The summary function I would use a little bit later in the process, after my data has already been categorized and coded, and I'm summarizing across bits of text. So not just a single segment, but I'm usually looking at, for instance, all of the data that has a particular code attached to it, and I'm working on distilling that data down into a summary of all the data across the code. Does that help? So in my teaching process, I would teach the paraphrase function early in the session, whereas I would teach summary functions towards the end. Thanks for that comment, Barak. That's really interesting. Being able to show everything in QTT, it's a great tool for that. Absolutely. Yep, thank you. All right, thanks everyone. I'm going to go ahead and close the session. Thanks for being here.